So far, in quantifying causal effects, we've focused on estimating average causal effects, which give us an overall sense of the effect of a treatment in a population or in subgroups. In this video, we'll discuss mediation analysis, which encompasses a set of tools for breaking down the different components of a treatment effect. Consider a treatment A and an outcome Y. When we draw an arrow from A to Y in a causal diagram, we usually don't mean that changing A directly leads to Y changing. Nearly always, there's at least one intermediate variable along this causal pathway. For example, the effect of A on Y might go through a mediator variable M. Here, A leads to M, which leads to Y, but there's also a direct arrow from A to Y. This direct arrow could represent that A acts directly on Y, but it could also represent that there's just another causal pathway from A to Y that does not include the mediator M. Representing the mediator explicitly on this diagram allows us to distinguish between two types of effects that may be of interest. The indirect effect, which is the effect of A that is mediated by M, and the direct effect, which is the pathway that does not involve M, and which may or may not actually be direct. We'll make the ideas of direct and indirect effects more precise momentarily. So note that the A to Y diag was not wrong if we wanted to know the average causal effect of A on Y. But sometimes we want to quantify the effects of the treatment along different pathways. And this is exactly what mediation analysis aims to do. To have a concrete context in mind, we'll refer to this example as we introduce ideas. Studies have examined how cognitive behavioral therapy, referred to as counseling therapy, affects depressive symptoms, as measured on a scale. One randomized trial found that counseling therapy led to increased use of antidepressants, represented by the mediator M. In this setting, the average causal effect is not the only quantity of interest. Direct and indirect effects are also of substantive interest. The direct effect represents the psychological effect of the therapy, and the indirect effect represents a completely different mechanism through antidepressant use. To better define direct and indirect effects, we need to set up some potential outcome notation. So YA, as we've been using all along, is the potential outcome for the response variable Y under treatment A equal to little a. So in our example, this is the depressive symptom score that would result if everyone received or didn't receive counseling therapy. Similarly, there's a potential outcome for the mediator variable, MA. This is the antidepressant use that would result if everyone received or didn't receive counseling. So note that YA and MA both reflect interventions on only treatment. We can also define YAM, the potential outcome for the outcome variable Y, if both treatment A and mediator M were intervened upon. Here, this is the depressive symptom score that would result if counseling therapy had been set to A equals 0 or 1, and antidepressant use had been set to M equals 0 or 1 for everyone. So using this potential outcome notation, we can define different direct and indirect effects of interest precisely. One such effect is the average controlled direct effect, or CDE. In potential outcome notation, it can be expressed as shown here. It's the average effect when comparing the average potential outcomes under everyone being treated and everyone being untreated, and when the mediator has been set to little m. In other words, m has been held constant at little m, and we're seeing the effect of changing the treatment. Hence the name controlled direct effect. We are controlling m, holding it fixed, which blocks the indirect causal pathway through the mediator. This allows us to just see the direct effect. Note that the CDE is a function of m because its value can be different depending on the value of m chosen. In the context of our example, the CDE answers the question, when we hold antidepressant use fixed to block any effects along this indirect pathway, what is the direct effect of counseling therapy? This is a way of getting at the psychological effects of the therapy rather than the medication effects. So the controlled direct effect can be of interest from a policy standpoint because it captures what happens from the result of a clear, uniform intervention on the mediator. For example, in a certain situation, psychiatrists may be required to refrain from prescribing antidepressants. This amounts to fixing the mediator at 0. In this setting, the controlled direct effect is exactly the causal effect we care about. The two other types of effects that we'll discuss in this video are called natural effects, the natural direct effect and the natural indirect effect. They're called natural effects as opposed to controlled because instead of controlling or fixing the value of the mediator at some constant, they involve the potential outcome for the mediator. This potential outcome being the value of the mediator that would naturally result in response to intervention on treatment. These natural effects end up being very useful because the sum of the natural direct and indirect effects is actually equal to the average causal effect. This is useful for enhancing our mechanistic knowledge of causal effects because it provides a way to decompose the ACE. How much of, what fraction of, the causal effect is due to one pathway or mechanism versus another? Let's look at one of the natural direct effects, NDE. We can define two of these, as we'll see in just a moment. So to define this, we'll need to use M0, the potential outcome for the mediator under no treatment. This is the antidepressant use that would result under no counseling therapy. This NDE is the average effect when comparing the potential outcomes under treatment and under no treatment, and when the mediator has been set to M0, which is its natural value under no treatment. The double use of potential outcomes can be a mouthful to express, so let's break down the interpretation of this effect in the context of our therapy example. Suppose that we were able to intervene on antidepressant use in a way that we could let it be as normal, as natural, if no one in the study were undergoing counseling therapy. That's the M0 part. We might do this by asking doctors to decide on antidepressant recommendations before announcing the availability of the therapy and ask that they adhere to these recommendations. We could then randomize counseling therapy. The resulting changes in depressive symptom scores can be viewed as the effects of counseling sessions themselves, direct effects, because we've held constant the mediator values, antidepressant use, as natural for each individual, as natural in a setting without counseling. This way of holding the mediator fixed at a potentially different level for each individual is more natural than the controlled direct effect, where the interpretation involves imagining fixing everyone's antidepressant use at a uniform, constant value. Because in general, it's harder to imagine intervening on the mediator to let it be as normal under no treatment, this natural direct effect has a less clear policy implication if policy requires intervening on the mediator. But this effect is still of scientific interest because it captures the effect of treatment along a particular mechanism, which might inform policy decisions or subsequent investigations. If, in this example, the direct effect of counseling therapy was close to 0, this would suggest that more mental health benefits are being conferred via access to medication. Note that the natural direct effect that we just discussed involved fixing the mediator at M0. There's no reason we couldn't think about fixing the mediator at M1, its natural value, in a setting where all were treated, all received counseling therapy. For this reason, there are actually two natural direct effects for a binary treatment, NDE0 and NDE1. NDE0 reflects the M0 in the effect definition. NDE1 reflects the M1. For these direct effects, in both cases, the mediator is held fixed while we vary treatment. Which one of these is more of interest depends on context. Would we like to imagine a situation where the mediator is acting as natural under treatment or no treatment? The answer to that might be informed by the status quo. Is the population of interest already in an M0 or M1 setting? It might be informed by safety. Is an M0 or M1 setting safer or less risky? Let's talk about the natural indirect effect. This time, we fix the treatment at 1, and we compare the situations where the mediator takes its treated value M1 and its untreated value M0. The key difference here, as compared to the direct effects, is that we allow the mediator to vary naturally in response to changing treatment. In this way, because we're no longer holding the mediator fixed at a constant value, the changes in outcome we see reflect the A to M to Y causal path. In the context of our example, all receive counseling therapy. So the comparison in this indirect effect is not capturing the effect of the counseling sessions because this is the same for everyone. We instead compare a situation where antidepressant use unfolds as if all received therapy, this is the M1 part, to a situation where antidepressant use unfolds as if all did not receive therapy. This is the M0 part. Allowing antidepressant use to vary, hypothetically in response to treatment, keeps this indirect AMY causal path open, while the direct causal path, A to Y, is closed by having everyone receive treatment. And just as there were two natural direct effects, there are two natural indirect effects, depending on whether we're interested in a situation where everyone receives treatment, NIE 1, or everyone does not receive treatment, NIE 0. The natural direct and indirect effects can be harder to think about because they involve imagining more complex hypothetical worlds where we intervene on the treatment and the mediator in seemingly inconsistent ways. For example, treating everyone but letting the mediator be as if untreated. It turns out that the sum of the natural direct and indirect effects equals the overall average causal effect, which can be very useful. The overall average causal effect can be expressed as shown here, a contrast between the potential outcomes when all are treated and the mediator acts naturally in response to treatment, and when all are untreated and the mediator acts naturally in response to no treatment. So check for yourselves that this is the same as the sum of the natural direct and indirect effects. The implication of this is that the natural direct and indirect effects, if the natural direct and indirect effects are of the same sign, we can view each as the fraction of the overall average causal effect. These allow us to quantify how much of the overall causal effect is due to the direct mechanism, how much is due to the indirect mechanism. So we've discussed various effects of interest in mediation analysis, but how do we actually estimate them? And in more complex and realistic causal diagrams, what concerns about non-causal paths arise? We'll explore these questions in class, but for now, the big picture overview is that we'll consider many different types of non-causal paths in our causal diagrams. These will include the usual non-causal paths between treatment and outcome, but also between the mediator and outcome, and between the treatment and mediator. While we've drawn problematic non-causal paths here in this diagram as confounding paths, more generally, selection bias can also be a problem in the mediation setting too. Our normal requirements for achieving conditional exchangeability using observed variables will be expanded. They'll be expanded into additional exchangeability requirements involving the treatment, mediator, and outcome. In order to estimate direct and indirect effects, we'll see that we can use models for M, the mediator, as a function of treatment and a conditional exchangeability set C, and we can use models for Y as a function of treatment, mediator, and that conditional exchangeability set C. If we assume that we've accounted for all possible types of confounders and non-causal paths as shown in this DAG, then these regression models can help us simulate potential outcomes and thus compare appropriate sets of potential outcomes to estimate these direct and indirect effects.